Good morning, everybody. Welcome to the Build in Digital Micro Conference, looking at innovation in the architecture, engineering, construction industries. The AEC industry is undergoing a rapid change due to the adoption of new technologies such as 3D printing, AR, VR, machine learning, digital twins, BIM, and drones. These innovations offer opportunities for improving design, construction, and operation of buildings and infrastructure, as well as addressing challenges such as material costs, labour shortages, inflation, and sustainability. The industry is expected to grow significantly in the next few years, driven by the demand for more efficient, resilient, and green solutions. This morning's micro conference will explore some of the trends and also challenges and opportunities that are shaping the industry in 2024 and beyond. So I'm delighted to say that we're moving on to the third and final keynote for today's micro conference. It's my pleasure to introduce somebody who is shortlisted for our Building Innovation Awards for the Innovator of the Year category. So no pressure, Don. I'd like to introduce Don McLean, who is the CEO of IES, who is talking performance digital twins for decarbonising buildings.
Thanks for that. So just as a starting point, I want to kind of set the scene a little bit. The key two words in that sentence is decarbonising buildings. And it starts from the design, it continues the refurbishment and how the people use the buildings. And as we all know, the buildings are a major cause for the carbon emissions. And as a consequence of that, it means you need to look at things a little bit differently. And increasingly, people that are working both in the design and the operation of buildings, the responsibility on them to make sure that what they're doing is the best it can possibly be to reduce the carbon emissions in that particular building. And as a consequence of that, we need better tools. We need different tools to kind of do that. There'll still be in the design phases and operational phases, but we'll need to tie them up a lot closer. They need to kind of be unified. And what we see is the fact that we create a digital twin at the start and use the digital twin through the whole life cycle of the building. But the digital twin's got to be in a position where it can actually work in tandem with the building. But also it means in the design stage that it's absolutely critical that we try and do that as best as possible so that we create as least problems downstream. And as a consequence of that, this is where we have been working hard for IES been around for a long time. Some of the kind of facts and figures associated with us from that perspective. But we are trying desperately hard to develop technology to set it up in such a way that we can deal from the cradle to grave of a building and try to make it emit as little carbon as possible. Obviously, we need to take account of other things like embodied carbon and things like that. But the design stage is an important part. It's a small part of the building's life cycle, but it's a very important part because that sets the scheme for how easy it's going to be in the future to keep that building decarbonised. So it's an enormous responsibility in all of us that's in this industry, but it's one that we've got to look at. And what we're trying to do is develop the technology that gives you the ability to do that. So as we all know, buildings are extremely complex and dynamic from that perspective. We can do decarbonisation at the extent of everything else, because if somebody's got to spend, 5 million to do their house, then that's not going to work. We've got to look at how the cost balance of all that goes. I think the other thing is that people are much more aware of comfort and well-being and things like that. So that's got to be incorporated into what we do technology-wise. We need to look at the financial risk and what that means and how we can take that into account. We also need to look at data challenges, how we get data from buildings and so on and so forth. We need to look at how we can make sure that the building operates optimally all the time. And at the same time, we've got to balance that against all other people's targets, because again, if it costs too much, people won't be able to do it. So that's a major issue. I think the thing is that retrofitting will become important, and many of you will probably be involved in retrofitting as well. there's something like 80% of the buildings in 2050 are already built. So this is where retrofitting becomes really, really important. Also, the thing is that by 2060, we expect the population to be going to about 10 million. And that's up from the 8.4 million we have just now. And the growth in the global population is enormous. And the trouble is the planet will not have the resources to be able to service all of that. We're struggling to do that at this moment in time. And if you look at Earth Day, it looks like we need 2 Earths to meet the demands of humans at this moment in time. That's going to be even more strenuous. I think as well as the fact that the challenge of decarbonisation, new buildings, because you don't know what you're really doing there, you don't have the information. And this is where our kind of approach will be able to try to mimic the building as close as possible, to give us the information that allows us at the design stage or at any stage of the building life cycle to try to see if we do things, how could we make that building better. But to retrofit, we need to treble the amount of retrofit work that we do just now over the next few years well, probably forever, to try and make sure that the buildings are as energy efficient, decarbonised as much as possible. So how do we test that we're deploying the right strategies? So this is where the digital twin comes in, to be able to have a model that's remarkably close to the actual building. In fact, you look at the sensor information from the real world against our virtual sensors from the model. They need to be very close together, and that's what we'll be working on to make sure that happens and make sure that we deploy the right strategies from that perspective. I think it's all about this as well as about de-risking situations, right? So make sure that people are going to retrofit properly, and all of this needs to kind of start now. What we're trying to do is provide the tools that allow people to do it from that perspective. And I think the thing is getting the balance between, in the short term, energy, carbon, comfort and costs. But I think as we move forward, carbon will become more and more important. So we need to look at this, as we all know, from the whole life cycle of the building. And that's absolutely critical, because the embodied energy is huge in many ways. And also, at the design stage, we're looking at the design of the building and so on and so forth, but buildings are highly dynamic. Within a year or two, they're different. So we need to maintain, be able to look at the operational aspect and minimize operational emissions as much as possible. Obviously, there's a lot of other approaches coming through by which we can monitor different things. And all of these are processes with which we're looking and having some association with our softwares using a lot of this stuff. But how can we make it easier to kind of do this and make these kind of approaches work more effectively? So I think the thing that we've done is we've kind of taken our energy modelling capability, but we've added, it was always physics-based, but it's now even more physics-based to try and deal with the complexity of trying to make buildings decarbonised as much as possible. So for us, a lot of it is kind of 4 easy steps. What you do is you look at, if we're looking at, say, for example, the first retrofit of a building, it would be saying, right, let's get the information in. It could be from BIM and other sources and things like that. But the idea being is we can build a good physics-based model as quickly as possible in the building. Once we've got that, we can then start to look at how we start to look at different scenarios with it, and start looking at things like decarbonisation pathways. What do we do at the first step, the second step, the third step, the fourth step? Those steps might have 3 or 4 years in between. So when you do the first one, it's 3 or 4 later, you do something else. You would need to actually then start to look at what's changed in the building and so on and so forth, because it will have changed. So again, all of those dynamics can get captured in all of this. When it comes to implementation, we want to make sure that we optimize the operation of the building as much as possible, because it's going to be key to keeping carbon emissions down. And investing towards net zero is going to be something that needs to be done with an understanding of who gets the benefit and who pays for it. There's a lot of issues there that we need to kind of look at. And at the same time, once we've done that, we want to be able to monitor it, make sure we know what's going on. And then at the appropriate time, we would then repeat the process. Now, the reason we would repeat the process is that decarbonisation won't happen in a single step. we've typically got to about 2050, everybody's saying that it's the kind of target. I think it's much more urgent than that, but even just saying that, you would do this process in a building maybe say every 4 or 5 years, just making sure that it's operating well. Or if, say, for example, a new tenant comes in, take the chance to do it then. So it's going to be a repeated exercise in terms of decarbonisation. And this is where a lot of the skills at the design stage have got to be redeployed at this stage and start to look at what happens at each decarbonisation event. In terms of the digital twin, our model is effectively always been a digital twin. We never, I only really started using the word digital twin about 10, 12 years ago. Basically, we're starting to use digital twins, and as I say, we've been using it for a long time. The aspect of this is to try to get as close as possible to the real building and how it's performing. From that perspective, what we've got is, if you look at that kind of little building there, we have got what we call virtual sensors and virtual BMSs. And what can happen is that in a building like that, we might have something about maybe say 40, 50,000 virtual sensors that we can get time series information from, as if it was from the actual building that was there, and we can then start to tune these. All those extra sensors gives us the ability to augment the actual sensor data with inside the building, which are reference points for us. And we kind of calibrate the virtual sensors to the real sensors on a regular basis to make sure that all of that is working as best as possible. And from this, because we're doing it live, we get the information that we can actually identify that something's not working right and we can do something about it. But all of this helps make the decisions about how we make the building operate as efficiently as possible, and make the best possible decisions as far as that's concerned. So basically, this kind of diagram is just saying, look, there's a lot of stuff that in the data input side that we've got to kind of bring together, including information from sensors and various other bits and pieces, real live sensors, and then bringing that in using both AI and machine learning that built around what we can do on the physics side of things. And then from that, we can then start to look at how we can take the information coming from those different sources and how we can make the building perform as best as possible through actionable information. So that means that with this source, we can make sure the building operates as well as possible to satisfy the needs of people, which is becoming greater in terms of what they want to, how they want to feel comfortable and so on inside the building. Capturing all of that is extremely important, and that's what we can do. The big thing that we've been doing, and the thing that's generating a lot of interest at this moment in time, is our first tool that really is merging everything that we've just said there. So we call it iGuess Live. And basically what we're doing, and that's a screenshot, is several screens superimposed where we're looking at different things. The major screen there, we're looking at different values, different sensor information that's coming through there. Some of that might be live, real sensor data. Some of it may be virtual sensor data. But it's very difficult to tell the two apart. But irrespective of that, we can take that kind of information and feed it into these kind of dashboards that people can check both, from a live perspective. If there's anything that's a concern, we'll flag it up and send it to the people that are operating the building and let them know what's happening. But the idea of this is that the availability of information that's coming through from both, from live information, from simulated information, and also from likes of AI information. And from that, we can then start to make sure that we can then feed the information to our customers or the people that are operating the building, so they have got the right information to be able to act at the right appropriate time to make sure the building doesn't drift and make sure the information for that building is as good as possible. So this kind of thing of actionable intelligence, we identify where there's an issue and we flag it up. Also, what we're trying to do is, sort of verify that we're keeping energy costs and carbon savings all within the parameters that we've set. We also want to be able to look at other things like indoor air quality and so on and so forth, to make sure as well, because again, it's about looking at well-being of people within inside the building at the same time. So there's a lot of parameters there, but this is the first of the tools that we're bringing through. Let's get the capability of doing this kind of whole life cycle and addressing the whole life cycle of the buildings, and us taking direct action with the technology, to run that digital twin in parallel with the real building, in order that we can make sure that we're looking ahead to make sure that we can monitor and inform the physical building, and the physical HVAC systems, etc., to tune them so that they operate at the absolute optimum performance. We've started this, our first version of this is actually now up and operational. It was done with the University of Liverpool. They were quite excited about doing this, be able to tell it to students, so that this is kind of world first. The building's been used in this kind of way. Over a period of about half a year, what we've done is we've verified that we've managed to make about 23% savings in the energy consumption, and then there's another £25,000 cost savings associated with that. So it's a significant effect, and the feedback we're getting from the facility managers is it was really useful just to be able to do a quick visual check of seeing what was going on, and they could do that anytime they wanted. So what we see is that this is just the start of what we're doing with Liverpool. So we expect significant savings and these buildings to be much better prepared for the future. And with that, thank you. Any questions?
Thank you, Don. That was a very insightful presentation. Thank you. Have we got any questions for Don, please? Gillian, is that you?
Yep, I was just had a quick one there, and it was regarding the retrofitting. There is a problem out there, obviously, and I've seen it when I've gone to conferences myself, in that there really isn't enough buildings to house all the people in the UK. But obviously that causes its own problems, and I just wondered, don't think you touched on it much in your presentation, but it's just regarding the tenants in those buildings already, because when you're retrofitting, then clearly there's people already living there some of the time. I just wondered, how do you address the sort of data security issues and the privacy of real-time monitoring, because that can obviously be an issue. So
yes, I think there's two aspects to that. I think that when I'm talking about retrofitting, I'm not expecting to be done every 6 months. I think, but to the same extent, if somebody doesn't retrofit their building in every 10 years, that's okay. The purpose of our technology is that we would help whether it's been monitored by somebody, some firm or something like that, or internal, or if it's a residential type way. The idea is that we're given information to say, you're using too much energy here, or why don't you use your washing machine a later part of the day when there's maybe not a lot of other things on at the time. Try and keep a level load. There's a whole variety of different things that, depending on the scenario, we could put together. So the residential is one of the more complex areas that we need to deal with, because I used to stay in a high flat, 13 floors up, and if you think about how am I going to get to be able to decarbonise that building, right, or decarbonise my house? I can hardly put a heat pump outside the building, right, and then pipe it all the way up to the house, right, up to my floor, so I can use it, right. So that's not very practical, right. And there's other aspects of that, of the fact that that a lot of these buildings are if we retrofit them, they're going to take a lot of money to kind of do it. So that becomes a big issue as well. So all we can do is provide the technology that enables people to be able to do these kind of things. And I mentioned before the cost of it, right? At the moment, if somebody's trying to put heat pumps in around about their house, right, it's going to cost a lot of money, right? To actually decarbonise a building is going to cost a lot of money. And this is the kind of thing that why it's not getting done and why people are shying away from it. But part of it also is the fact that they don't have the tools with which they can evaluate this effectively and actually have a cost understanding of what it's going to be and do something about it. The governments around the world are very, very good at saying we need to decarbonise, we need to do this, we need to do that. The problem is they're doing nothing about it, right? Really all the kind of the decarbonisation objectives of COP and so on and so forth have not materialised, right? We've now hit the 15 degrees C limit all around the year, which was the absolute limit that had been set for 2050, right? And we've got it in 2024, right? You know, that there are real serious issues and we can see the effect of climate change at this moment in time. What we're not seeing is the worst point of it yet. Even if we're to decarbonise tomorrow, it's still going to be around for a long time because we've set this, there's a massive inertia here and that inertia is still to kind of come through. So it's extremely concerning and what we're trying to do is, as fast as we can, is provide the technology that enables people to do this. And from that, because we can do it all, it's not possible. And what we are looking at is partnerships with people, because again, this is an existential problem, right? We've got to do something about it. And the trouble is that the legacy we're leaving for our grandchildren and great-grandchildren is horrendous, even if we stop doing things just now, right? And we're not going to be able to stop doing things just now. Population growth is going to make all of this worse, right? You know, the dwindling resources, you know, so I'm not going to go too far because it'll just totally depress you, right? But we've got to be realistic that something's got to be done. And what the objective is, and this tool that we're bringing out, IES Live, is the first that we're really trying to do that is addressing the operation of the building much more. And there's got to be greater connectivity between the design and the operational process so that we can deal with decarbonisation. This is about massive collaboration globally. If we can't do that, future generations are going to suffer dramatically.
I agree, actually. And just a follow-up question, although it might depress everyone a little bit more, is what, as you're one of the biggest innovators, I'd say, that's sort of like pushing decarbonisation, what is your opinion on, this is a question I had in a conference recently. Do you really think we're gonna get that target of, you know, being completely net zero by 2050, or in some cases 2030?
No.
I thought that might be the case.
Based on the way the governments are operating around the world at this moment in time, the answer is clearly no. If the governments were to engage in it, there's a chance. But, and I'm saying this in a, let's say that if I be totally honest about it, right? I've been working towards this for many years, right? And because the thing I've identified a long time ago is that the operations thing, we operate in the design side, and that's perfectly fine because that addressed the kind of markets. But over the last few years, we've been trying to develop the tools that allow us to do this. So the plan is to develop technology that helps us to help people decarbonize what they're interested in, be it a building, be it a campus, be it a community, be it a country, be it a continent. We need to think at that kind of level. And it means that there's other things we need to think about as well. You know, do we decide that there's some countries we don't like, so therefore we won't help them decarbonise? We can't do that because it's good. You know, there's massive problems for us in terms of what we're trying to do here. But to the same extent, we've got to try because nobody else is really trying to do this.
Yeah, exactly.
And I think, and I think that the thing is, this is what we're sort of looking at is not about us saying, you know, so this is where you've got to put the future against money. So yes, we want to get funds to allow us to do more development in this kind of area, right? And we want to grow from that perspective. But we need to do that because if we don't do that, we won't give everybody a chance of decarbonising the built environment. So I've kind of taken it on as that is our corporate responsibility. Our mission as a company is that we will help decarbonize every building in the world. That is our objective as a company. Total decarbonisation with our technology. If other people join it, great. What we're looking for is other people to bring in other tools that help us do it. But it's collaboration. We need united collaboration around the world to enable us to decarbonise. And because the built environment is such a big part of it all, it's incumbent in us all as people in that industry to try and make the industry as good as possible. We can't do everything about every industry, but we can look after ours.
Yeah, and I think that's the point. I think if everyone does it the way that you guys are doing it, then maybe that's the start on the future of decarbonisation. So hopefully that'll work.
Correct.
Thank you very much for that. Brilliant answer.
Okay, thank you.
Thank you, Gillian. Have we got any more questions for Don, please? Yes, Shervin.
First of all, thank you very much, Don, for your presentation. It was very good. My name is Shervin Yusuf Sada. I'm head of construction at GS1 UK. You probably never heard of the GS1 UK, but it's fine. But we are very open to collaboration, Don. So we are into identification products, not in the construction, but across all their sectors as well. And when you're talking about the digital twin and also the physical model, my question was about how do you identify those assets in the in the physical model? What is are you using any like a GUID from the BIM models? Are you using your own ID? What ID are you using? Because our goal at the GS1 UK is kind of creating that common language that can be used for the energy, for circularity, for every aspect. And we are working towards that. And that's why I would like to have maybe an offline conversation with you and how we can collaborate, how we can create an open standard that, as you mentioned, is that we can implement your technology to more than just UK, and we can do that globally with with less interoperability issue. So again, just to repeat my questions, how do you identify asset? What is the ID that you are currently use to identify, for example, the heat pump or identify the air conditioner in the building?
Okay, so I think again, you mentioned there, we don't want to try to do everything ourselves because we know what we're expert at, we know we're not expert at, right? And this is where we see collaboration is important. Okay, now what I think that we're looking at is that say there's something we haven't included it because we've not known too much about it, and then this will happen in the process of what we're doing, right? What we're looking for is other companies that we can collaborate with, right? And more or less get them onto our mission, right? Because we've got the mission, we can tell the story, we can express what we're trying to do, and people can see with what we've done that this is what we are doing, okay? But the thing is that I want to concentrate in what we do best, and I want to get people who are concentrating what they're doing that complement what we're doing, that our mission becomes their mission, so that therefore we can work together in order to achieve much more, much quicker and much more effective than we can on our own.
Amazing, though. As a not-for-profit organization, we are open to collaborate, and we're happy to have a further conversation offline. So I will be in touch with you.
The only thing is we are for profit, and the reason we're for profit is we can invest as much as we can into doing this as fast as we can.
That's absolutely fine, but I'll talk about the GS1 later on in our conversations, but we are more than happy to collaborate.
Look forward
Thank you very much, Dan.
Okay.
Thank you.
Well, you should meet each other on the 17th of October, guys, at the Hilton Deansgate for the Building Innovation Awards, because I believe you're both attending. So you can have a chat in more detail if you don't meet sooner. Don, I've got a very quick question before we come to summarise the session. I was going to dig a little bit deeper into that Liverpool University project you mentioned.
Yeah.
And obviously caught some of the figures there. Was it £23,000 worth of savings in 7 months?
23% reduction, which got equated to £25,000.
£25,000.
And that was over a 4-month period.
Wow, that's quite eye-catching, to say the least.
Yeah.
Obviously, I mean, away from obviously the environmental impact and the decarbonisation journey to net zero. The cost savings alone are amazing. So is that purely on energy costs, or is that other costs as well?
Yes, yes. But let me into a secret, okay? The thing is that in that exercise, that was a new building that was put together. Everything was kind of operating at its optimal format. We were in helping them with our technology to kind of do that. And then we created the IES Live with getting the sensor information and so on and so forth, and then mixing that up with the simulation information in order that we could see what's going on, be able to predict ahead, be able to make suggestions about what was done. Okay, that is all perfect. But in other buildings, the cost of retrofitting this stuff, right, is going to be very high, and it's going to be an obstruction. So there's a lot of issues that will stop people doing this quickly. They may have to be forced governmentally to do something about it, but the thing is, at this moment in time, it's still a big effort. Now, we're talking to a lot of very, very large companies, but even for them, the cost of decarbonisation is going to be much higher than they think. And that's one of the biggest issues. You know, if I use this example, I've got a neighbour who is an 82-year-old widow, right? She lives on her husband, or dead husband's pension and things like that. You know, but the big problem is she can't afford to decarbonise, right? You know, but even if you had maybe say somebody at that age, kind of age, and they had some money, there is tremendous concern for me that you know, people could kind of suss this out and be going to somebody like that and saying, "Oh, we can help you decarbonise your house. We could do this, this, and this." Is a scam, right? You know, people have, you know, it's trying to get to that kind of situation where you can protect someone to make sure that things like that don't happen to them, and you do it in a sensible way, you know, that's cost-effective way for them. But the same thing happens with the big companies, right? You know, they might get overcooked. They might, you know, in their haste of trying to do something, they don't get the right information. You can't do this in a spreadsheet. You can't do this with AI in its own, right? So what are you going to do? And I think what's happening is that with over the last few years, more and more large companies, as well as small companies, are looking at this, right? And what we see is the fact that, you know, we don't care where you're from, what you're about. This is a global problem. We've got to deal with it as a global problem. There's things that we all need to do that we don't like, with maybe working with somebody in a particular country. But you know, we can't just turn around and say, well, we'll leave that country. We're not going to do anything with them, right? But there's not a fence around that country in terms of carbon is concerned, right? So we've got to look at this as a global issue and address it from that perspective.
The human condition will always be a consideration, won't it?
Correct. Correct.
Thank you, Don. Right, so let me move on to a quick summary of our three keynote presentations this morning. First up, we heard from Darren Meads at Brixis, who explained how the Brixis software can work with your organisation, taking you through the main workflow and the benefits of how Brixis software compares to other BIM systems. Questions that Darren answered came from Francesca, who talked about automated and manual actions that are both needed to create the BIM model or outcomes required. Charlie asked about the mechanical benefits of the software, which needs more explanation offline. Finally, Darren finished off with the adoption of BIM in the wider industry through the supply chain, which seems to be slowly happening. And it's like going from a Samsung phone to an iPhone. Nice kind of layman's analogy for my benefit there, Darren. Secondly, we had Francesca at ISG. Francesca started with diving in with the innovation on the digital technology side, explaining how BIM is not a tool, it's a process. She also explained how she works with BIM at ISG, some exciting tech in using the open space tool, real-time images, which is a really big step forward in using a Google map of the buildings, which highlights problems you might not see otherwise. Francesca then talks about the future tools, and how the future lies in collaboration, linking to her being a regional head for London for women in BIM, and how obviously that is a great collaboration organisation and opportunity for anyone of any gender to join and attend. And then finally, we heard from Don. Don's the CEO of IES. Don specifically looking at digital twins, about performance, how they can obviously help to decarbonise environment and buildings. Don's presentation was fairly broad. We went through the challenges and the benefits of using digital twins into new and retrofitting buildings. The population problem is is the overarching reason why we need more buildings and need to retrofit existing buildings. Obviously, there's a consideration of modern residents in order to get to this net zero goal in 2050. Obviously, we need government buy-in and to actually support that. Don touched on some wider issues within decarbonisation, but the main point Don would make that IES can do what they can do, but obviously collaboration and working with partners is essential. All companies in construction need to collaborate as well as the government to make that their main goal. That was today's micro conference. Thank you very much to our 3 keynote speakers. Thank you very much for everyone who attended, and we hope to see you at a future micro conference. Check buildingdigital.com/micro conferences for our full list of online events for the next 12 months or so. Thank you again. Appreciate you all attending, and hope to see you at a future event.